In this video, I explain Oldham coupling. So here you see this is the diagram of Oldham coupling. It consists of flange A, flange B with a slot and central floating disc E as shown in a figures. Now this above is the assembly diagram of Oldham coupling, and here you see this is a flange A. In a flange A, one horizontal slot is provided. This is the flange B. Here one vertical slot is provided, and this intermediate part it is called as the floating disc E. In some book, its name may be given different. Instance of flange A, they mention driving flange. Instance of flange B, they mention driven flange, and instance of floating disc E, they mention the intermediate flange. Okay, so its name may be different in a different book. The disc E having a tongue T1 and T2 at a right angles. Now here you see this is a tongue T1 and this is the tongue T2. So these T1 and T2 are 90 degree to each other, means they are right angles to each other, means one is horizontal and one is vertical. So angle between these both the tongue is the 90 degree. Tongue T1 is fitted into the slot of flange A. So this tongue T1 is fitted into a horizontal slot of a flange A, and they are provide or they allows horizontal sliding relative motions, means this floating disc E is able to move horizontals in a flange A, while tongue T2 is fitted into the slot of the flange B. So here you see in a float disc E, the T2 is vertical and this tongue T2 is fitted in a flange B. Here you see it's a vertical slots. Okay, so they are allows the vertical sliding relative motions. So what happens when the one flange is allow horizontal motions, one flange is allow vertical motions? Now that we discuss this. This right angle motion of tongue on the slot will accommodate lateral misalignment of the shaft when they rotates. So when the shaft is rotated, some lateral misalignment is there, so it is absorbed by the floating disc E. Means floating discs are able to move horizontal as well as verticals in a flange A and B respectively. Oldham's coupling is used in connecting two parallel shafts but not in alignment, and their axes are at small distance apart. So in this diagram here you see this is the axis of shaft A or a axis of the driving shaft, and this is the axis of the driven shaft. They are parallel to each other but it have a some distance. At that time we use the Oldham's coupling. So thank you for watching this video. If you learned something, then like the video and don't forget to subscribe my channels for watching the more video related to basic mechanical engineering or elements of mechanical engineering subjects or other subject of mechanical engineering. For BME subject, various link is provided in descriptions as well as in car. For other subject, I request to visit the playlist.